So what would happen if we taught a computer how to kanban? We would probably learn a little bit about WIP limits. So let's talk about that tonight. All right. So my name is Dean Chandler. Welcome back to the channel. This is What Would Dean Ask? Tonight, we're going to talk about a simulation that I did after we taught a computer how to kanban. So let's set the simulation up. So this is the second time we've run this simulation and talked about it on this channel. I'll link the first video down below in the show notes. So what we did is we took a simulation, we ran it 100,000 times with different WIP limits, 3, 5, 7, 11, 13, 21. So we had 7 people, 7 pickers. So this is like simulating a 7-person team. So each picker, person, team member, they have about a 50-50 probability of completing a work item each simulated day. Okay. What will happen in the simulation, if the team has not reached its WIP limit, then a new work item will be started if work cannot be completed. So it's like having a deck of cards. All the red cards means we can complete work. All the black cards means that we cannot complete work. And then we can start work if we haven't reached our limit. Items are completed first in, first out. Each simulation burns down 100 items. Okay, so you think get kanban, feature bond game, things like that, right? So this is what we're simulating this using Python. I'll also link to the actual Python code that runs the simulation on my GitHub, so you can reproduce the results if you want to. All right, so pulled in all the data from the simulation, like I said, 100,000 times, different WIP limits. So the first thing we want to look at, let's just look at Little's Law. Okay, so what happens? So we've got our cycle time and our throughput and our work in progress. Okay, so the first graph you see on the screen here is the cycle time, then you see the throughput, and then you see the the average work in progress throughout that simulation. So even though we had a WIP limit, right, it may not actually reach that limit. So we want to see what the average work in progress limit. So first thing you want to notice here is that the lower the WIP limit, then the lower the average cycle time is for the item. Also, what's lower though is the average number of items that team can get done per day. So seeing this trend shows me that Little's Law is definitely holding true even in this simulation. So the more items that we allow to be done simultaneously, the probability of that cycle time going up, but we can get a little bit more done. Now here's what's interesting. Even as we allow the WIP to go up to, say, 21 items, we're only getting another half an item done on average per day. So not a lot. But the cost of that is that the average cycle time is going up 5-6 fold. Okay? So let's think about that for a minute. So the probability that the cycle time is going to go up 6 times by allowing the WIP to go up to 21 is only going to get us an extra half an item per day. Very much in Little's Law. And you see what's happening here, right? Is that Little's Law, because of the resources on this team, so there's only 7, right? Then the throughput is always going to be constrained by by those resources on that team, by them allowing, and then the probability of them being able to get the work done. So as we allow the WIP goes up, then the cycle time goes right there with it. So simulation is definitely showing Little's Law is in play. And not only is it in play, we can absolutely control our cycle time by controlling our WIP. And we can also control our throughput to a certain degree. We don't get as much variation there by controlling our WIP. Okay? So is that the question then we need to ask ourselves is how much faster then is that half of item? How we can get more items done by allowing the WIP to go up, but is it worth it? So let's look at the time to complete. So if you look at the second chart here, this is showing the time to complete with just WIP of 5, 7, and 21. Okay, so yes, on a good day, the probability that we can complete the items faster, in this case, we could complete it as fast as 60 days if we allow our WIP to go up to 21. But look how much overlap there is. So even if we limit our WIP to 5, there's a probability that we can complete those items in, say, 63 days. So it's faster, yes. Best case, it's 17% faster. Worst case, it's only 5 days or 5% faster. I'm not seeing a huge case here yet for allowing our WIP to go high, especially given that when we know that for individual items, because of Little's Law, that if our WIPs goes high, then the probability that our average cycle time for individual items is going to go high. Again, is it worth it? So let's look at the average and then the max again. Okay? So the average is the first graph here, and then the max is the second graph here. So on average, we completed items in 2 to 3 days. Every 2 to 3 days when we held our WIP of 5. So that was 7-person team, WIP of 5. So less than the number of people on the team. Okay? Look at what happens. Look at this green part here. Look at what happens again. So the probability that the average cycle time goes up 4, 6, 8, 10, 12 days. So only 10% of the runs were in that 3-day range, the same place where the 5 was. But then but the other 90%, of the simulations, the average cycle time was higher. 90%. Okay? Now, look at the max, though. Same thing with the max. 80% of the maximum cycle time is higher. 80% of the time, even the max. So when we allow it to go up to 21, that 80% of the time, it's going to be slower than the slowest item that came out when we limited it to 5. So here's what I think you need to do. And you hear this all the time from us Kanban folks. And what I'm showing you using the simulation is we're not just blowing hot air. We're not blowing smoke. There's a reason that we tell you to limit your WIP. I'm saying you should at least limit your WIP. And I've said it on this channel before, and I'm going to say it again. Limit your WIP to at least the number of people on your team. But it's even better if you limit it to 1 or 2 less than. Yes, I know that flies in the face of, well, who's going to not be busy? This was just a simulation. They're always going to be busy. They're going to be helping each other. They're going to be learning from each other. They're going to be learning, right? They're going to be taking a class. You can't be 100% busy. When you're 100% busy, you're overworked, you're going to slow down. It's a traffic jam. So what happens when you teach a computer how to Kanban? It shows you that you need to limit your WIP to the number of people on the team, if not less. Thank you. Don't forget to hit the like button on the video. Don't forget to subscribe to the video so you can see more about these. We'll do some more simulations like these. Thank you.